So here this is the second part of solving this O-levels chemistry paper 1 multiple choice October-November 2024 paper 12. So I've solved the first 20 MCQs with full explanation in the first part of this video, and today we're going to be starting with MCQ number 21. If you guys want to see the first 20 MCQs, I'm going to give a link in the description box below about that video. You may go and watch because it's going to be really helpful. So let's get started with MCQ number 21, which says which solid reacts with dilute hydrochloric acid to produce a gas. Okay, we have read about acid reaction with a few things that produce a gas. We know that acid plus metal is going to give me a gas, and the second thing I know, acid plus a carbonate can give me a gas. Okay, so let's get started. Carbon is not a metal, so it will not give me a gas. Copper. Okay, now many of you think that copper is a potential metal, so it might give me a gas, and copper is like a good transition element that can react, but you should know that copper is below in the reactivity series than hydrogen. This is hydrogen and this is copper. So copper cannot replace hydrogen from the acid. Let me give you an example. For example, you have HCl. So basically, when you're reacting a reactive metal with an acid, what you're trying to do is basically this H in the acid. You're trying to replace it with the metal. For example, if you're reacting zinc with HCl, so what you're trying to do is replace this H in the HCl with zinc to make zinc chloride, ZnCl2. So that's what you're trying to do. The metal tries to replace the H in the acid. But unfortunately, copper is less reactive than hydrogen. So copper cannot replace this hydrogen. It cannot form copper chloride. It needs to be more reactive than hydrogen to displace it from its compound. So what will happen is that copper will not react. Magnesium oxide. Okay, magnesium oxide is a basic oxide going to react with an acidic oxide to form salt and water. But what we're looking for, our eyes should be on the prize, which is a gas. So magnesium oxide, despite its reaction, won't produce a gas. Okay, next is sodium carbonate. Well, we know that acid plus carbonate react to give salt, water, and carbon dioxide gas. Let's write down the reaction for this. Okay, we have sodium carbonate, which is Na2CO3. Plus we have hydrochloric acid, which is HCl. And now what we're going to get is a gas, salt, and water. What is going to be the gas? Carbon dioxide gas. What else? Water. These two are confirmatory products. And the third one is going to be a salt. The salt is going to be sodium from the carbonate and Cl from the acid. So it is going to be NaCl. Okay, so there, if we balance it out, we're going to put a 2 over here and I guess a 2 over here. So that's the equation, and we are done with making a gas. Okay, which 1 mole per dm cube aqueous solution has the highest pH? Okay, people tend to confuse the pH. What you're going to look for in the pH is a pH scale. Over here you have the pH of 1, and the highest pH you have is 14. In between 1 and 14 you have a pH of 7. Okay, 7 is your neutral pH, okay? And this above 7, okay, the pH above 7 is your, basically this part is your alkaline pH. So the highest pH you're looking for is going to be an alkaline pH, because the more the pH increases, the more towards alkali you go. And the lower pH is going to be the acidic pH. Okay, HCl probably going to have an acidic pH less than 7, so it cannot have a high pH. Sodium chloride. Remember that salts, they have a neutral pH. Sodium chloride, NaCl, is a typical example of a salt. So it's going to have exactly a pH of 7 because salts are neutral. Sodium hydroxide. Okay, sodium hydroxide is a alkali. That's a hydroxide, metal hydroxide. Metallic hydroxides are alkalis, or you can say they're bases, but because this base is soluble bases are called alkalis. This is an alkali, and a very, very, very strong alkali. It is going to have a high pH above 7. So the answer is going to be option number C. And sulfuric acid again is a an acid, is going to have a lower pH lower than 7. Moving on, oxide Q reacts with separate samples of dilute hydrochloric acid and aqueous potassium hydroxide. Okay, now you come across a very interesting thing, that there's an oxide Q, okay, and what's basically happening is this oxide Q is a bit strange, is a bit peculiar or bizarre in its behavior. What's happening is it's reacting with an acid, dilute hydrochloric acid, and the second thing it's reacting with is aqueous potassium hydroxide, which is an alkali. So this peculiar oxide reacts with both an acid and an alkali. So an oxide which reacts with both acid and alkali, what kind of oxide do you consider it to be? It is an amphoteric oxide. So the oxides that react with both acids and alkalis to form salt and water are called your very own amphoteric oxides. Okay, now one thing important about amphoteric oxides is that we have only two amphoteric oxides in our syllabus, despite being a lot like beryllium, tin, but in our syllabus we only have two. So learn these two. We have zinc oxide as an amphoteric oxide, and we have lead oxide as an not lead, sorry, this is not part of the syllabus. Though lead is an amphoteric oxide, but in our syllabus we don't have lead oxide, we have aluminum oxide, sorry, Al2O3. So these are two that are part of the syllabus. Apart from this, if they use lead oxide or tin oxide or beryllium oxide that are amphoteric, they are going to tell you that this is an amphoteric oxide. Okay, so these are two that should be in your knowledge, and the rest you're going to be provided. Okay, both reactions produce salt and water. Confirmatory that it's an amphoteric oxide. Which statement is correct? Q is acidic? No. If it was acidic, it would only react with an alkali. Q is amphoteric. That's correct. That's the reason that it's reacting with both. Q is basic. Okay, Q is not basic because if it was basic, it would only react with an acid. And Q is a non-metal. Non-metallic oxides are basically acidic. Okay, their majority of times they're acidic, so they'll react with alkalis, not with both. It's probably a metal oxide. Why a metal? Because zinc oxide, lead oxide, this aluminum oxide, all amphoteric oxides are metal oxides. Okay, moving on to the next question. The table shows 4 methods used to prepare pure salts. Okay, we have 4 methods and we're preparing pure salts. Which row shows the method of making a pure sample of each named salt? We have acid plus carbonate and we want to make copper sulfate. We have magnesium sulfate, okay, and then we have silver chloride. The good thing over here is that you want to make copper sulfate. Then why would you, okay, acha, that is acid plus metal is going to be magnesium sulfate. Okay, that can be made. Copper sulfate can be made with acid carbonate. You take sulfuric acid, you take copper oxide. Silver chloride by precipitation. Okay, by precipitation you should know that we make insoluble salts, and that's correct. Silver chloride is an insoluble salt. All chlorides are soluble except for silver and lead, and by titration we make salts of extremely reactive metals. Reactive metal salts are made by titration. So over here we are making our sodium chloride by titration, and sodium is an extremely reactive metal. So option A is correct. Okay, let's find out the mistakes in B, C, and D. Acid plus carbonate. In this, we use a moderately reactive metal. We cannot make sodium sulfate. For that, we need titration because sodium is extremely reactive. So this makes it incorrect. Again, for acid plus carbonate, we need a moderately reactive metal. We cannot use potassium and sodium carbonates because they're extremely reactive. So all of these are crossed. Okay. Which property determines the order of the elements in the periodic table? Obviously, their atomic number, the masses, not the masses, the number of electrons, no, the number of neutrons in the nucleus, no, the protons. It's the proton number that basically determines your arrangement. Let's go and see the periodic table for ourselves. Look, this is the proton number. Let's start from over here. Over here, the proton number is 21. The next one, 22, 23. 24. So they are arranged according to the number of their protons, 26, 27, 28. Like this, we continue and each element has a unique proton number. So it's arranged according to increasing proton number. Moving on to 26, which statement explains why helium and neon are unreactive? Because they're noble gases, they're full outer electron shells, they don't need to gain or lose electrons. Atoms tend to react because they have incomplete shells. They both are gases at room temperature? No. Oxygen is a gas, but it's reactive. They both have 8 electrons. No. Okay, that might seem very, truthful statement, but that's not. Why is that not? Because look at helium. Helium is helium 4, 2. Helium has 2 electrons in its outer shell and 2 protons. Okay, so helium has a duplet electronic configuration, not octet. Okay, neon has 8, but helium has 2 because the first shell has a maximum capacity of 2, so helium has a complete first shell. So that's helium. Okay, they both have equal number of protons and electrons in their atoms. Okay, they both have, that's correct that they have equal number of protons and electrons, but that does not explain their unreactivity. Even the most reactive potassium has equal number of electrons and protons, but that does not make it unreactive, that just makes it neutral. Okay, they both have all their occupied electron shells completely filled. That's correct, they have full electron shells. Okay, moving on to the next MCQ, would say substance X conducts electricity in solid state, substance X is malleable. Okay, which statement is correct? Okay, conducts electricity in solid state and is malleable. You should know that it should definitely be a metal. Metals conduct in solid state, ionic compounds don't. X conducts electricity by the movement of electrons between layer of negative ions, between layer of positive ions. Because if you know a metal structure, you should know that's a metal. You have your positive ions, and between the positive ions, you basically have your electrons. And these electrons move between the positive ions to conduct electricity. X conducts electricity by the movement of positive ions? No. Ions do not move in metals. X has a giant lattice of positive ions in a sea of delocalized electrons. That's correct. And X has layers of atoms, not layers of atoms, layers of positive ions. Okay, so that's a giant lattice of positive ions. You have a lot of positive ions and you have a sea of delocalized electrons. These are your delocalized electrons. So option C is correct. Aluminum and copper are good conductors of electricity. Why is aluminum used in overhead electrical cables instead of copper? Because look, overhead electrical cables, these are your poles. Okay, I'm not good at drawing, but just consider these are your poles, and between the poles you have these wires sagging like this. Look, if these wires are made of a metal, aluminum has a proton number of 27. Copper has a proton number, this is aluminum. Copper has a proton number of 64. So aluminum has a less proton number. Aluminum is less heavy. So you need a metal that's less heavy. Have you ever held aluminum foil in your hand? Aluminum is such a reactive metal, a good metal, but still aluminum foil is very light because the proton number of aluminum is less, so it's light. You make your aircrafts out of aluminum so that the density of the aircraft is low and it can basically travel in the stratosphere. Okay, so that's what you're trying to do. That's why you use aluminum, because if it's low density. Okay, because you need it above ground level, so you need a low density that can remain over here. Otherwise the wires would require a lot of energy and they would try to fall down if it would made up of copper. So aluminum is above copper. The reactivity series don't basically matter because copper is unreactive and aluminum has a layer of Al2O3 above it that makes it unreactive. So both don't kind of react. Aluminum is less dense than copper. That's the reason, because you need your wires above, not below like this. You don't need want to see wires like this. So that's why. Okay, the oxide of Z is reduced by heating with carbon. Okay, what is Z? Okay, that means that Z is, or whatever Z is, it is less reactive than carbon. Okay, so carbon is above Z. Okay, that's why it can be reduced by carbon. Means carbon can displace. For example, you have ZSO4. So basically, if you add carbon to it, carbon can replace this metal from its salts. Okay, aluminum, no, aluminum is above carbon. This is your carbon, this is your Z. Not aluminum, calcium is very above. Okay, now you have a competition between magnesium and zinc. You should know that magnesium is above carbon and zinc is below carbon. So that's what you got to learn. So it cannot be magnesium, it has to be option D, which is zinc. Because zinc is below carbon. And I guess they kind of help us by writing Z. That was, the answer was zinc. So kind of like the Z over here and the Z over here. Okay, a metal O contains an oxide MO. The metal M forms colored compounds. Okay, what does this colored compound tells us? This colored compound tells us that it's going to be not probably, confirm a transition metal. Okay, when a piece of iron is placed into a solution containing ions of M2 plus, M is displaced, which means M is less reactive than iron. Why less reactive than iron? Because iron can easily displace M from its solution. Which row is correct? Possible method of extraction of M from MO. Okay, electrolysis only, not only electrolysis or heating with carbon, both can be done. Okay, because electrolysis can be done for any metal and heating with carbon can be done with metals below carbon. Because Fe is below carbon, that's why you reduce it from its oxide by using carbon. And because M is even less reactive than iron, it can also be reduced by carbon because it is even below iron, so it is more easily reduced by carbon, and electrolysis can be used for anything. And density of M is going to be high because they've told us that it forms colored compound. That tells us it's a transition element, and transition elements have high density. So it's going to be option B. Iron can be extracted from hematite. What is the maximum mass of iron that can be produced from 500 kilograms of hematite? So what they're trying to test over here is, do you know the equation of extraction of iron from hematite? So let's write down the equation. Whenever you have massives, they're asking for maximum mass, minimum mass, whatever, you got to look for equation. So the equation is, you have Fe2O3 plus I guess 3 carbon monoxides, you form 2Fe, and plus 3 carbon dioxide. So that's the equation. And now you got to write a balanced equation. After that, you got to see the mass of this and this. So we know that, firstly, I know that this Fe2 and this O3, I have to take out its MR to see that how much of Fe2 O3 we have. So I guess iron has a AR of 56. Since we have 2 iron, so 56 times 2. And then we have 3 oxygen, so 1 oxygen is 16, so 16 times 3. Let's do this. 56 times 2 plus oxygen has 16 times 3. Okay, that's 160. So that gives me 160. That means 160 grams of Fe2O3 will produce how many grams of iron? 2 times iron. So 2 times 56. Let's do it. 2 times 56, that give me 112. So 112 grams of iron. So 160 grams of Fe2O3 gives me 112 grams of iron. So 500. Okay, over here it's kilogram. One tip to do this is that you take both masses in kilogram. Consider this is kilogram and this is kilogram, okay? Because that won't matter at the end. Because you just add, those 3 zeros after everything, so they get cancelled. So don't worry. So 500 will give me X mass of iron. So X equals to 500 into 112 upon 160. So 500 into 112. 500 divided by 160. That's going to give me 350 kilograms of my iron. And that makes it option C to be the correct one. I hope you understood this. We just had to make a balanced equation. And then from the equation, we just had to find the mass of our Fe2O3. Then we had to find the mass of iron. We had to be careful about this 2 right here. That means we had to multiply 56, which is the AR of iron, with 2. And after that, we said that if 160 grams or kilograms of Fe2O3 can give me 112 kilograms of iron, then 500 kilograms of Fe2O3 will give me X kilograms, and I just found out the value of X. Okay. Which row describes an advantage and disadvantage of fertilizers? Okay, advantage is going to be improved plant growth, and disadvantage is going to be addition, not addition. It's going to be removal of oxygen from water. So damage to aquatic life. Okay, that's basically removal of oxygen from water. So it's going to be option C. Because advantage, why damage to aquatic life? Because it causes eutrophication. You should know what eutrophication is. Though the things, details are not required in syllabus, but if you're biology students, you should know that what happens in eutrophication. Basically, your nitrates and phosphates, I'm going to just give a quick review in 5 seconds if you get it. The nitrates and phosphates from your agricultural fields, after rainfall, they leach or drain into your rivers or water bodies, and after that, they cause excessive growth of your producers, which are your algae. It causes an algal bloom. And that algae grows on the surface of your water, and this is your water. This algae covers your water surface. What basically happens is, when this algae dies, bacteria decomposes it, and bacteria in the water uses up all oxygen decomposing this algae. And when bacteria uses up all the oxygen, what basically happens is the other organisms inside water, the marine life, don't get oxygen because bacteria has used all oxygen in decomposing algae that was caused by the nitrates and phosphates and fertilizers. So now the water body does not have enough oxygen. So the aquatic life is damaged. Okay. So that's entire eutrophication. Which row about adverse effects of air pollutants is correct? Methane. Okay, that's all cramming. It caused global warming. Okay, methane, oxides of nitrogen, they cause respiratory problems. Okay, and particulates, they cause cancer. So it's going to be option A. I just learned them all. This is all cramming based. How many different unbranched esters have the molecular formula C4H8O2? Okay, we are looking for unbranched esters, and how many unbranched esters? Okay, we cannot do a branching, so it's obviously going to be 2. Why is it going to be option B? Let me tell you guys. Because trying to think, C4H8O2. To make this, you need. Wait a second. You have other options. Let's consider the options. Okay, first let's consider all the options. You need 4 carbons. Okay, you just need 4 carbons. Think about it. The first option I can think of is I take my methanol. Okay, that will have 1 carbon, and I take my propanoic acid. Okay, propanoic acid. That's gonna give me my methyl propanoate. Second thing is that I take my propanol and methanoic acid. Okay, 2 esters. Okay, the third ester I can make is my ethanol and my ethanoic acid. Okay, can there be a third, fourth ester? Oh, if I take my. No, I guess only 3 are possible. Okay, so I guess it's gonna be option C. I just made 3. I could make 3. Is there any fourth one possible? Let's think about it for a second. Methanol, ethanol, propanol, and butanol. No, I don't guess there's a fourth possibility. Okay, moving on. Petroleum is separated in a fractionating column. Which statements are correct? The compounds at the top of the column are more volatile and have lower boiling points. That is correct. Because as you move up, okay, you have your, lower fractions above and higher fractions with more carbons below. So as you move up, the melting boiling points decrease and they are more volatile. Volatile means the ability to for example, your perfumes. Okay? Take example of perfumes. Why can you smell perfumes in the entire room when you have just sprayed a single spray on one corner? Why can you smell it in the other corner? Because it's volatile. Okay? Even if you have a perfume bottle, you don't even spray it. If it's open, or a nail polish remover, if you've ever smelled it, you can smell it easily because it's volatile. Okay? Okay, one is correct because it has very less carbon atoms. Not carbon atoms, I mean smaller carbon chains. That's why it's volatile. The compounds at the bottom of the column are more viscous. That's also correct. Viscosity basically means your thickness kind of thing. Okay? Example is honey and water. So because honey is more thick, so honey is going to be more viscous. And as you know, the number of carbon atoms increase, the viscosity, the I would say the physical state of the substance increases. It turns more type of solid. So it's going to be more like honey than water because the viscosity is going to increase. Viscosity is the ability to flow. So 2 is correct. Number 3, the chain length of the molecules at the bottom of the column are shorter. No, that's incorrect. It's basically longer. The carbon atoms increase. So it's going to be 1 and 2. Okay, which statement about hydrocarbons is correct? Okay, the thing I would like to tell you, hydrocarbon is C6H12O6 a hydrocarbon? Please tell me. Okay, first choose your answer. Is it a hydrocarbon or not? How many of you say yes? To all those, I'd like to tell, a hydrocarbon is only a substance that contains carbon and hydrogen only. Because it has oxygen, it is not a hydrocarbon. Okay? So you cannot consider it to be hydrocarbon. Okay. Alkenes are unsaturated, which means they are less soluble in water than alkanes. No, that's complete not true. Okay? Alkenes contain a higher percentage by mass of carbon than alkanes. Okay, that's correct. Okay, I'll tell you why that's correct. Just read the other statements first. Let's read the cracking large alkanes produces only smaller alkanes and hydrogen. No, it also produces smaller alkenes. Okay, the presence of a double bond in an alkene means 1 mole of alkene will react with exactly 80 grams of bromine. The presence of a double bond in an alkene means that 1 gram of. Okay, presence of double bond in an alkene means that 1 mole of that alkene will react with exactly 80 grams of bromine. That's incorrect. It will not react with exactly 80 grams. Let me tell you with how much it will react. Look over here. Bromine is 80, okay? Bromine is 80. But how does bromine exist in natural form? Br2. So, Br2 has to be accounted. So, this 80 has to be multiplied by 2, which makes it 160. So, it will react with exactly 160 grams, not 80 grams, okay? So that might seem confusing, but please don't be intimidated by the statements that should be 160 grams, because bromine does not exist as Br only, it is Br2. Okay, now try to understand what I'm going to explain you in statement B. Alkenes contain a higher percentage by mass of carbon than alkenes. Why? Because look, alkenes, for example, you have C3H6, that's an alkene, okay, that's characterized as an alkene. And then you have C3H8. What is that? That is an alkane, which has more percentage by mass of carbon. You might think that both have equal percentage by mass of carbon because both have 3 and 3 carbons, but that's incorrect. Alkenes have higher percentage by mass of carbon. Percentage by mass means that total mass you consider, and above that you put the mass of the substance you're looking for. So what basically is happening over here, this H6, you have less hydrogen. So it's a comparison between hydrogen and carbon. Over here you have more hydrogens. Okay, now let's take out the percentage by mass of both to make you guys see. Over here we have 3 carbons, so 12 times 3. Okay, above we take the percentage of carbon, below we take the percentage of entire thing. 12 times 3, that's going to be 36, plus 6 because hydrogen is 1, so plus 6 times 100. Let's see what comes out. Okay, 12 times 36 plus, that's going to be, I guess, 42 into 100. So 36 divided by 42 times 100. So that's a 85.71%. Okay, just look how I'm going to do it. Okay, for this, the percentage by mass of carbon is 85.71. Now let's do for this. It's going to be 36 above C3 upon H8. H8, it's going to be 42 more. So it's going to be 42, 3, 4, 44. Now let's see about this. 36 times 100. Okay, 36 times 100 divided by 44. It's 81.81. Now see for yourself, 81.81. Over here, the percentage by mass of carbon is 81.81. Over here, it's 85. So alkenes, definitely, for same propene and propane, you have more carbon over here. The carbon amount is not more, but in comparison it's more, because the denominator is going to be smaller because you have less mass of hydrogen. So that's why alkenes have a higher percentage by mass of carbon. Okay, so that's what you have to understand. And lower percentage by mass of hydrogen. Okay, 2 statements are shown. When ethanol is made from glucose by fermentation, each glucose molecule produces 2 molecules of ethanol. Okay, each glucose molecule produces, let's write down the equation for this. You have C6H12O6 and you form C2H5OH and you form 2 moles of ethanol and 2 moles of your carbon dioxide. So when ethanol is made, each glucose molecule produces 2 molecules of ethanol. That's correct. Statement 2, when ethanoic acid is made from ethanol, the ethanol acts as a reducing agent. Okay, how is ethanoic acid made? Okay, so what you do is you take your ethanol, you add in it a oxidizing agent, that's KMNO4, and then you form your ethanoic acid. So basically this is your oxidizing agent, and ethanol indeed acts as a reducing agent. So this is also correct. Which description of the statements is correct? Statement 1 and 2 are both true. Statement 1 is true. Statement 2 is false. That's incorrect. Both are true. Statement 1 is false. Statement 2 is true. No. A is correct. Both statements are true. Okay, statement 1 and 2 both are false. No. Okay, in a titration, 25 cm cube of sample of 1 mole per dm cube sodium hydroxide is exactly neutralized by 16.2 cm cube of dilute sulfuric acid. What is the equation for the reaction is shown? What is the concentration? I guess that's extremely easy. You just have to first find the moles of your sodium hydroxide. Let's do it. It's moles equals to concentration times volume. Concentration is 0.100. Volume is 25 upon 1000. Why 1000? Because over here it's cm cube. We take the volume in dm cube. Let's find the moles. Okay, 25 divided by 1000 multiplied by 0.100, that's going to give me 0.00025 moles. Okay, 0.0025 moles of this NaOH. Now I make my mole ratio. What's going to be the moles of my H2SO4? I guess the most important thing in equation is this. Okay? You just have to look the moles. 2 moles of this form 1 mole of this. So you have to form a mole ratio. H2SO4 ratio NaOH. So 2 moles of this forms 1 mole of this. So 0.0025 moles of this would form X moles of this. So find the value of x to find the moles of H2SO4. Okay, 0.0025 divided by 2, 0.00125. So the moles of H2SO4 equals to 0.00125. Is it 0000? It's 00. Okay. Now I have my moles for sulfuric acid. What do I need now? I need to find the concentration. I have the volume of sulfuric acid as well. So 0.00125 is the moles upon volume. Volume is 16.2, but I cannot take this because this is in cm cube. I have to convert it in dm cube by dividing it by 1000. 1, 2, 3. So it's going to be 0.0162 is going to give me my concentration. Concentration equals to my moles. These are my moles upon my volume. So let's divide it. 0.0162 divided by 0.0162. That's going to give me a 0.077. A 0.077. What's that? Option B. Done with this. Moving on to 39, which says that 3 liquids X, Y, and Z are tested and the results are shown. Okay, we have tests. We have liquid X, we have liquid Y, we have liquid Z. We have anhydrous cobalt chloride. Okay, it turns from blue to pink. Okay, over here there's no change in Y, and in Z it turns from blue to pink. A blue to pink indication of this cobalt chloride paper, anhydrous cobalt chloride, tells us that there is water present. So there's water in this Y thing and there's water in this Z thing. Okay. So and there is no change over here, that means no water. What may be deduced about X, Y, Z from this information? X is impure water, pure water, or pure water. Look at the boiling points. Okay, 100-degree boil of water. What do you guys think? That's impure or pure water? Always remember, okay, that's a very big tip I'm going to give you guys. This color change only tells us either water is present or not. It does not tell us about the purity. This blue to pink tells me water is present. Either it's impure or pure. This 100 degrees Celsius tells me that it is pure water. This 103 tells me it is impure water. Okay? So over here it's going to be, for this one, because it's 100 degrees Celsius, it's going to be pure water. So pure water, because it does not change in Y. There's no change, that means there is no water. So there's no water, and because it's 103 and you know that pure water exactly boils at 100 degrees Celsius, that means this is impure water, making option D the correct one. Remember, melting and boiling point, they tell us about the purity. They tell us either water is pure or not, and blue to pink basically tells us either water is present or not. Okay, so this blue to pink cannot tell you either water is pure or not. Okay, so that's what you have to remember. Last question, which says compound Q is soluble in water. Solution of Q gives a white precipitate when dilute sulfuric acid is added. Okay, it is soluble in water. So let's figure out the soluble ones. Barium chloride. Okay, all chlorides are soluble. Ammonium chloride soluble, ammonium nitrate soluble, this soluble, and this soluble. Okay. A solution of Q gives a white precipitate with dilute sulfuric acid. With dilute sulfuric acid, what's going to give you a white precipitate? Barium sulfate. So you need your barium thing in this Q. So it can either be C or D, because both of them have barium, and barium sulfate is going to give me a white precipitate because all sulfates are soluble except for barium, lead, and calcium. Moving on, when Q is warmed with aqueous sodium hydroxide, okay, and aluminum foil, a gas is produced. Okay, that's qualitative analysis, which you had to learn. And if you know that this gas is going to be ammonia gas, NH3, which turns damp red, litmus paper blue, and that's going to be a test for nitrate ion. That means option D is correct, and the solution is barium nitrate. This test was for nitrate ion, and this above test was for barium ion. So I guess with that we come to an end of our paper, and thanks for watching, and consider subscribing to the channel. That's going to mean a lot, and bye-bye.